Hello everyone, welcome back. This is Engineer Sen Wasapi, and in today's lesson we'll be looking at what is called electromagnetic radiations. So before we begin, don't forget to hit that like button and subscribe. Alright, let us understand these so-called electromagnetic radiations. In most books, they are just referred to as electromagnetic waves. Alright, let's get to it. So, by definition, from the title, electromagnetic waves, we define electromagnetic radiations to be radiations that are electric and magnetic in nature. That's basically how we define these electromagnetic waves. There are about 7 electromagnetic radiations that we need to know. There's a shorthand system that we use to remember these. It might sound a bit funny, but with time, you'll realize that it's quite important. So, you start with radio, go to micro, then infra, VZ, ultra, X, gamma. Alright, so I'm going to practice this about 5 times. So, you do it with me. The first part, I'll do it alone. So, to remember this statement. Radio micro infra VZ, ultra, X gamma. 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 Now we're going to do it together. I know it might sound a bit corny, but trust me, you'll use it as a shorthand system. So let's do it together. It's going to be radio micro infra VZ, ultra, X gamma. Radio micro infra VZ, ultra, X gamma. Radio micro infra VZ, ultra, X gamma. 2 more. Radio micro infra VZ, ultra, X gamma. The last one. Radio micro infra VZ, ultra, X gamma. Alright, let's see how this has benefited our knowledge. So remember, from the shorthand system, we're saying radio micro infra VZ, ultra, X gamma, which implies that the first radiation we have is radio. So those are radio waves. So radio, what follows after radio? Yes, micro. So we have microwaves. Micro, infra, then we have the infrared rays. VZ, which is the visible light. Ultra, which is the ultraviolet rays. Remember, ultra X, so then we have the X rays. And finally, gamma rays. So remember, radio micro infra VZ, ultra X gamma. Alright, now that we know these electromagnetic waves, we need now to understand how they really work, which is where we have to look at their uses. But before we even do that, I want you to understand that as you move from 1 to 7, what happens is that there will be an increase in 2 things. The first thing will be what? Frequency. How frequent it is. Then the second thing is going to be energy. So as you move from radio going to gamma ray, you are having an increase in frequency and energy. Very important point. And as you move from 7 to 1, the following things will increase. You have an increase in the wavelength. So the wavelength will just be the only thing that will increase. So if you are asked to say, among the 7 electromagnetic waves or radiation, which one has the highest wavelength? Remember, from 7 going to 1, which means that 1 has the highest wavelength, which is what? The radio waves. So radio waves have the highest wavelength. And if you're asked to say, among the 7 electromagnetic radiations, which one has the highest frequency? Remember, as you move from 1 to 7, there's an increase in frequency as well as energy, which implies that gamma rays have the highest frequency. They are more frequent than any other electromagnetic radiation that we have. Now, in a similar sense, we say the same for energy. As you move from 1 heading to 7, you're having an increase in what? Energy. So you expect the energy to increase for particles or radiations that are moving from 1 heading to 7, which implies that gamma rays have the highest energy source. Now that we have understood how to remember all these things, I also need you to understand one thing, that all electromagnetic radiations fall under what we call progressive waves because they are able to transfer energy. And that's the main reason why we're saying that as you move from 1 to 7, you're having an increase in what? Energy. So that is the reason. All electromagnetic waves fall under what we call progressive waves because they are able to transfer what? Energy. Let's remember that. Now, before we even continue with any other aspect where we have to look at the uses of all these electromagnetic radiations, I just want you to remember something that is quite important. This is just food for thoughts. The first food for thought I want you to remember is that every time you look at the term wavelength, wavelength is symbolized with lambda, and that's a symbol for lambda. Wavelength gives you the length between two successive crests, or in short, you can define it to be the total distance between 2 points on a wave. That is what we call the wavelength. And other than that, we have the frequency. Now, frequency has a symbol which is just some fancy type of F. So with frequency, what you need to understand is that this involves how a wave repeats itself. Hence, this is like the number of waves produced per second. You get the sense? So frequency is literally directly proportional to the energy and inversely proportional to the wavelength. That is something you have to put in consideration. So frequency just talks about how frequent something is. So frequency will always be directly proportional to, so there will be that constant of variation, then to be directly proportional to the energy and inversely proportional to the what? To the wavelength. This is something you have to bear in mind. So be mindful about that. Then another thing you have to know is that energy just talks about the ability to do what? To work, your capacity or your enablement to work. Alright, so the next thing we're going to look at are the uses of these electromagnetic radiations. So to start with, we're going to look at these called the radio waves. So for radio waves, they're basically used in radios, that's to start with, as well as in television. Alright, that's in simplicity. Now, once we understand the uses of radio waves, we can now move on to the next electromagnetic radiation, which is simply just the microwaves. So the microwaves, basically, first, they are used in satellite communications. So they're used in satellite communication, and not just that, they're also used in cooking food. That's why we have appliances called microwaves. Yeah, so they're also used in cooking what? Food. Then the third one is basically the infrared rays. So infrared rays are basically emitted by hot bodies. These are literally emitted by hot bodies. And if I look at the uses, we are going to look at the use which is being involved in the use of what? Electric heaters. So they are used in electric heaters. Not just that, they're also used for cooking food. So in cooking food, as well as you can also put infrared cameras if you want. Then the fourth one is the visible light. So visible light is basically used for sight. That's one aspect you need to know. It's used for sight. So say for sight. Not just that, visible light is also used for fiber optic communications. So fiber optic communication. Okay, sorry about that. Communication. All right, other than that, now we also have what is known as ultraviolet rays. So ultraviolet rays are used for energy efficient lamps. So you can start by first looking at them in the use of energy efficient lamps. Energy efficient lamps. Then not just that, they're also used for sun tanning. All right, now after that, we're going to look at the sixth one, which is the X-ray. So X-rays are used for medical imaging, and treatment. So we can also look at medical treatment. Then we can look at the last electromagnetic wave, which are the gamma rays. So gamma rays are basically used to treat cancer, even though they cause cancer. So they are used to treat what? Cancer. Not just that, gamma rays can also be used for medical imaging as well. So you can also say medical imaging, just like that. So basically, these are the uses of the 7 electromagnetic radiations that we have. Now that we have understood the uses of electromagnetic radiations, we now need to look at the general properties of all electromagnetic radiations. So let's look at the general properties of electromagnetic radiations. So when I say general properties, I'm talking about properties that are applicable for all electromagnetic radiations, which are the electromagnetic waves. So what are these general properties? So the first property is that they are electric in nature. They are electric in nature. Not just that, we can also say that they are magnetic in nature. So they are magnetic in nature. Other than that, we can also add up the aspect that they travel at the speed of light in vacuum. When we say vacuum, we're simply talking about space. They all travel at the speed of light in space. I like to use the term space. It's more easy for people to relate to. Space, and that speed is 3.0 times 10 to the power 8 meters per second. Now, in addition, they obey the wave equation. Now, what is this wave equation we're talking about? The wave equation says speed is equal to frequency times the wavelength. So this is the wave equation, where V represents the velocity of speed, then F represents the frequency, and lambda represents the wavelength. Then, in addition, they have no charge. They have no charge at all. And lastly, they are all transverse. Now, when I say transverse waves, what we need to understand basically is that if you look at transverse waves, we have longitudinal waves as well as transverse waves. Now, when we say transverse waves, it means that the vibration of the particles are perpendicular to the direction of travel of the wave. That's what it literally means. Alright, thanks for watching. This is basically everything you need to know about electromagnetic waves. If you have questions, you can always reach me on WhatsApp on the line 077 149 5252. Remember to hit that like button and subscribe. You can also turn on your notification icon so that you can be getting more updates on the videos. Remember, slow progress is better than no progress, and let's always strategize in order to push for that distinction.